Hi ho, Miss Marsh here. Today we're going to look at section 2.10, which is change expressed as a percent. So this is going to be similar to what we learned recently. Our materials, make sure you have your notebook, writing utensil, and then you probably are going to want a calculator today. So we're going to find percent change and also how to find a relative error in linear and nonlinear equations. We're going to look more at linear though. So this percent change equation, now remember, whenever I have a pencil like this, that means you need to write this down. This is going to be your best friend for this section. So this is amount of increase or decrease and original amount. Now, to find our numerator, what we need to do is, if we know it's an increase, and I'll show you how to figure that out, we're going to do the new amount minus the original amount. But if it's an amount of decrease, we're going to want to do original minus new. So we're going to have to figure out which one is which. Usually it's big number minus small number, but we'll take a look at them. So you're going to want to make sure this gets down into your notes. Problem 1. A coat is on sale. The original price of the coat is $82. The sale price is $74.50. What is the discount expressed as a percent of change? So what we need to do is we need to find the change. So I need to think to myself, is this a decrease or an increase? So it was 82 and now it's 74.50. So since I went down, I know that we're going to be doing a percent of decrease problem. So I'm going to use the formula that was before here, this one. So I'm going to take the original amount, so 82, and I'm going to subtract the new amount, the sale price, $74.50. And then I'm going to divide by the original, which is 82. So now the numerator, I get 7.5 over 82. Now, once I divide this, I get 0.09 and then a bunch of other numbers. I just rounded. So we want this though as percent. So I need to take this times 100. And I get 9.0% or 9% change. So I have a discount at 9%. Problem 2. The average monthly precipitation, my goodness, for Chicago, Illinois peaked at 4.1 inches. The average monthly precipitation in December is 2.8 inches. What was the percent decrease from June to December? So they actually tell me this is a decrease. So I need to do original minus my new. So the original I know is 4.1 and I know my new amount is 2.8. So what I'm going to do then is I'm also going to divide by the original amount, which is 4.1. So I took 4.1 minus 2.8 and I got 1.3. I still got to divide by 4.1. Now if you do this on your calculator, you're going to get 0.317. So if I multiply that by 100 to get my percent, I get 31.7% decrease from June to December. Problem 3. A store buys an electric guitar for $295. Then the store marks up the price of the guitar to $340. What is the markup expressed as a percent of change? So what I first need to figure out, is this a decrease or an increase? So they bought it at $295. But they're going to actually sell it to you and me at $340. So that's an increase. So I know I'm going to be dealing with a percent of increase for this one. So what I'm going to do, I'm going to do the new amount minus the original, so 295, over the original. Remember, it's always over the original. So 340 minus 295 is 45, and over 295. Once I divided this, I got 0.153. There we go. Which, if I multiply that by 100, because remember when you change it into percent, I get 15.3% change. So they actually marked up the Qatar by 15%, which is pretty significant if you think about it. Relative error. Now, relative error is used a lot in chemistry class and also in science. What this is showing how much error someone has in their estimations. So this is the formula you definitely want to have down for relative error. Oops. You want to have this formula right here. So relative error equals the absolute value. So remember, whatever is an absolute value, if you get a negative inside, we're going to get a positive on the outside. So measured or estimated, so that's if they estimated something, minus the actual value over the actual value. So this is useful in chemistry due to the fact a lot of the time you can only get so precise with something that you measure, such as, let's say, volume in a beaker. If you know what the actual value is, you can say my error was 5%, which lets us know as a reader of your work that it is actually not too bad of a percent error. Now, if you have a really high relative error, that means that you did not estimate as well or as good as you should have done. So let's take a look at two problems like this. So problem 4 is about a rug decorator. So he estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet, so he was about a foot short. Not too bad. What is the percent error in the estimated area? So they want to know about area though. So I need to find the area of my two possible rugs. So his estimation, so I'm going to write off to the side here. Estimation, my area is, remember, length times width. So I got length times width, so 5 times 8, and that gives me 40. My actual rug is a 4 by 8, so 4 times 8, and that gives me 32. So I got my two things. Now if you remember, the formula that we had was measured or estimated in absolute value, so I start my absolute value here, measured or estimated, so I have an estimation of 40. Minus my actual value, which is 32, all over my actual value. So my actual value is 32. So I'm going to subtract 40 minus 32, and I'm going to get 8. It's still in the absolute value. Now, absolute value of 8 is going to be positive 8 yet. So remember, it only changes as a negative positive. It does not, and I repeat, it does not make a positive number negative. So then I got to go 8 divided by 32, which gives me 0.25, which if I multiply by 100 to get my percent, I get a 25% relative error, which is a pretty large percentage if you consider he was only off by 1 foot. Let's take a look at the last problem. You estimate that your friend's little brother is about 8 years old. He's actually 6.5 years old, so you're about a year and a half off. So what we need to do is we need to take our measured or our estimated, which we said was 8. See, an estimate was 8. And I'm going to subtract the actual. So he's actually 6.5 years old. And I'm going to put that in absolute value, remember. And then I'm going to divide by the actual amount. So 6.5. So 8 minus 6.5 is 1.5 divided by 6.5. And I get 0.23, which I know is 23%. So I have a 23% relative error, which is not as bad as the rug guy, but still it's pretty high up there. Usually you want less than 10% error to make your data look convincing. So that is the end of the show tonight. Please make sure your notes are fully done, and I will see you in class next time. See you later.